Okay, guys, let's continue where we had stopped. Just going a little behind. Okay, say assume that we've drawn this whole setup of transistors over here, and we have used the orange color one here as a cut MD layer here. Now let's take a scenario of a transmission gate. Okay, so there is a PMOS here, there's an NMOS. Two terminals are connected to each other. Now, if I were to be using a planar, right? I know that these two terminals are going differently to two different gates, right? I cannot place these two transistors one below the other. Just assume that this is a PMOS, this is a NMOS. I cannot place them next to each other in a with a small gap. Why? Because my gates would get short. So in a planar device, I would end up placing them slightly apart with one poly pitch difference, right? I would have to make the connection like this and then pull out the gate connections from here or from here, depending on whatever is feasible over there, right? You see that the amount of area what is lost, the amount of space which is lost over here, you would lose easily certain polys over here trying to implement this transmission gate structure over here. Whereas in this case of self-aligned layout styles, right, what happens is, like, assume that this is a PMOS and this is an NMOS over here. I need to implement this structure here. So when I'm placing them next to each other like this, because of the MD layer, these are automatically connected together, right? So what I will need is I need to ensure that these two gates are separate now. Okay, assuming that this is the connection what I'm trying to implement. This is separate, this is separate. Now when I'm placing these two transistors next to each other here, I need to cut this, else it would be an incorrect connection. So what I would do is I will just do a cut poly layer over here. I would apply another type of cut layer, base level cut layer, that is like how we have got CMD, cut MD to this. To cut the poly, we have got a layer called CPO layer or cut poly layer. Okay, so you are chopping off this poly. Thereby what happens that your sources and drains are automatically connected with this base level layer on right side and left side, and your gates are separate. Now you can conveniently make a connection, separate connections for this and this, but the amount of area what is saved over here is quite a lot. You don't have to juggle the devices here, right, left, and all of that, reroute the connections and all, extra resistance is added, extra metal connections are added over here. Now obviously in the end you will also have to put cut MDs over here, because these two are specific to this connection itself. You don't want to uh, end up connecting these sources and drains elsewhere, right? If at all there is a connection going somewhere on the top, you can just deactivate the MD layer over there and ensure the connection is running there all above. Okay, depending on how your floor plan is. What I'm trying to convey over here is, using the base level layers itself, you can do a lot of local connections. Okay, you'll be saving a lot of routing, automatic. It's kind of the arrangement is such that just by using the cut layers you can maneuver the connections. You can maneuver the connections very easily. If you want this connection, for example, if you want this connection to go above, you can just deactivate this or pull this cut MD layer inside, and this MD layer will go above. You can connect it to the neighboring devices what you have placed on the top. Same thing implies you can just add the cut layers and maneuver the connections the way you want. So whenever you are using any cut layer, right, the connection becomes different. This net has a different connectivity, this net has a different connectivity. Okay, let me take another example and try and explain you. Okay, so metal cut layers. Now I have spoken about base level cut layers. Now let's talk about metal cut layers. Okay, let me just clean this up. Oops, sorry. Okay, I'll just pick up the picture over here itself. Okay, so let me just take this device over here. Okay, I'm just placing certain devices next to each other. Just assume that there is connectivity over here. just for the sake of explanation, I'm arranging all the devices next to each other. Now, assume that I have to, these are all the diffusion devices. Diffusions are continuous, the metals are connected this way when you place or share the diffusions and all. Now, I have to, this is a kind of self-aligned dual patterning kind of setup over here, wherein you have just turned on the options and all the colors are shorting with next to each other. You know that these devices are separate to each other. Okay, you're aligning them, but yes, unless if it's the same connection, you will leave it as is. But if at all it's a separate connection over here, you will be using a cut layer, for example, here. Okay, if these two connections are same like this, you can leave it as is. You don't have to put a cut layer. Now, if these two devices are separate and you want to cut the connection over here, then you need to draw a cut layer. Generally, cut layers are drawn at the ends of the device. Generally, in standard cells, you end up drawing it at the edges like this. Or whenever you want to detour a signal over here, there is a continuity here, for example, and you want to make a connection at this point and this point. So you draw a cut layer here, and I'll draw another cut layer here. Depending on whether I'm using a red color cut or a blue color cut, we have color coding for cut layers also, right? So then you have the flexibility of making connections over here. So what's happening here is I am running using the same metal. I'm drawing a cut layer over here so that this signal doesn't go over here. This is a separate signal. Now keep in mind, whenever I'm drawing a cut layer, the moment I draw a cut, okay, or if you will end up having different signals. You can treat this side as a separate signal, this side as a separate signal. So when I draw a cut layer, if I don't draw a cut layer, it will create a short between two different signals. Okay, you will get a highlighting mark over here in the layout. It says that you have to draw a cut layer. The moment you draw the cut layer, the highlight goes away and it will be treated as a separate connection on this side and separate connection on this side. So you draw a cut layer, you draw a vertical metal one on top of it, and you have the option of maneuvering the signal, making a vertical connection from top to bottom over here. Likewise, say if I have to make a connection over here, from here to here, I will draw this and make a connection here. I mean, yes, you have to use different metals. I'm just showing for the sake of it, right? So what I'm trying to convey here is the metal layers also have a lot of cut layers in between. Depending on whatever metal you want to cut, you need to use that type of coloring for that particular cut layer over there. So we generally have cut layers for lower level, that is M0, M1, M2, and M3, right? You have cut layers for this. Now, depending on the technology, you have cut layers for all kinds of metal. Okay. So now generally we don't have for higher metals, the width is much higher and that is not required as per the technology as well. Let's take another scenario here. Okay, let's take this example here. Okay, so now you have two different connections here. This whole metal is running across and there's a gap in between. Right? Now this is a separate connection, this is a separate connection. Right? So what you can do is you can just by drawing a cut layer, okay, you are creating a separate net altogether. This is a separate net, this is a separate net, but still the metal is running through and through, right? You're getting rid of those vertical metal spacing DRCs, okay? Just by drawing a cut layer, you're making two different signals over here, okay? Now, if you ask me what is the difference between METRES and using a cut layer is, the METRES, as I mentioned, is the same net which is running across. Just for the sake of monitoring purpose, the designer tends to use a METRES layer, okay? In the layout, wherever you use, whatever metal you use, you need to update in the schematic. The designer will get the exact parasitics or the signal strength of this particular signal. They will monitor this with a different name, this side of a net with a different name, right? But the continuity is the same. It's the same signal which is running across. Okay? Whereas here, in this case, when you're using cut metals, right? The moment you use a cut layer and a color coding for this becomes a separate signal. This becomes a separate signal. This comes in very, very handy or it's used a lot when you're doing fine poly related layouts, or when you're dealing with self-aligned dual patterning kind of a layout style. Okay, so that's where that's the major difference between usage of cut layers and usage of metal resistor layers. Okay, so that's the major difference over there. Okay, if you have any questions, feel free to write into me and drop a message, and we'll be happy to answer your questions. Thank you.